Hello everyone, this is Yu. In this video, I will solve question 8 for homework 7. And for this question, we are already given the information that Poisson process formula is written like this. That's the probability of n t1, t2 equals to k and should equals to e to the power of minus lambda times t times lambda t to the power of k divided by k factorial. And for this question, we need to find out first the expectation of xt and the second r t1, t2. So let's look at the first question first. In order to solve the expectation of xt, we should list this formula first. According to the probability PDF property, we should get this to do the sum from k equals to 0 to the infinity, and this is the Poisson formula, and the sum should equals to 1. And if we conduct the derivative with the respect of lambda to both the left side and the right side, we can get this answer. The sum from k to the infinity and k times lambda k minus 1 times t to the power of k and divided by k factorial equals to t times e to the power of lambda times t. And if we multiply lambda to the both side, no matter the left side or the right side, we can get this part. It's the sum of k from 0 to the infinity, lambda to the power of k times t to the power of k divided by the k factorial equals to t times lambda times e to the power of lambda times t. And so far we can get the expectation of x of t, and this should be equals to the sum of k equals to 0 to the infinity k times e to the power of minus lambda times t and times lambda times t to the power of k divided by k factorial, and this should equals to t times lambda times e to the power of lambda t times e to the power of minus lambda t, and this answer should equals to lambda t. For the second part, we also need to conduct the derivative of this formula to the both side with the respect to lambda first, and then we can get the sum of k equals to 0 to the infinity k squared times lambda k minus 1 k to the power of k lambda to the power of k minus 1 times t to the power of k divided by k factorial equals to t times e to the power of lambda times t and times 1 plus lambda t. And if we also times lambda to the two sides, we can get that the sum of k to the power of to k to from 0 to the infinity k squared times lambda times t to the power of k divided by k factorial should equals to 1 plus lambda times t times lambda t e to the power of lambda t. And here we just need to, in order to solve the e x of t, we should get just plug this part into this part. We can get the answer is 1 plus lambda t times lambda t. And so far we can solve the rt1 t2. That should be equals to the expectation of xt1 times xt2, and the the answers, this formula should equals to expectation of xt1 plus xt2 minus xt1 plus xt1, and because those are independent, so we can just equals to this formula to the expectation of xt1 times xt2 minus xt1 plus xt1 square. And if we just use what we have solved from this part, we just plug it here, we can get that it is equals to lambda t1 times lambda t2 minus lambda t1 and plus 1 plus lambda t1 times lambda t1. And just do the simple calculation, we can get the RT1 T2. If T2 is greater than T1, we can get the answer is lambda T1 plus lambda square times T1 T2. If T1 is greater than T2, then the answer, then we should change this part. This part is xt1 minus xt2. So in here is this formula is the answer when T1 is greater than T2. So the RT1 T2 equals to RT2 plus lambda square T1 T2. So in conclusion, we should consider these two conditions. We can get the final form of this answer is RT1 T2 equals to lambda times minima T1 T2 plus lambda T1 T2. This is the answer for question 8. Thank you.